So now, you apply the P, you have moment, this is the BMD, and then since this case, we start from the fundamentals one, we have the E constant and the I constant, alright? So that makes the M over EI diagram or curvature diagram looks just like this, okay? Now, you get curvature diagram, this point you have zero rotation, so if you integrate your curvature with respect to x, that means it is the area of this triangle, right? If you integrate this with respect to x, that means the change, total change of angle from here to here, alright? So you end up with the theta, okay, T being half multiplied by PL over EI multiplied by L. This is the area of this triangle. So you have PL squared over 2EI. This is going in a counterclockwise direction. How's about the deflection? The deflection, if you recall, you will get the area, okay, and then multiply by that area multiplied by the distance from the centroid of the area to this location. What is that thing? I don't know. Something you learn and you find that if you don't do this, you don't get the points in the exam. Probably. Okay, what is the meaning of that thing? The area of the rotation, total rotation multiplied by the distance from the centroid. What does that equal? So, again, moment area theorem that you used to learn. You have the BMD. From BMD, you come up with the M over EI diagram. So for one M over EI diagram, okay, this is the deformed shape of the beam, okay, which is the result from this BMD. Okay, you must remember that TA subscript B thing, right? That, what the hell is that? Okay, first thing is that if you draw the tangent, well, this thing may not be in the exam, but it just maybe try to bring up the physical understanding from, well, because we have extra time from this class, maybe Friday class, so okay, we can talk about something, right? So the TA subscript B, okay, tangent that is drawn from the point A and then refer to point B. So what is that? At one point, okay? At one point, so if this is a very small dx, if this is a very small dx, and this is your curvature that you compute over here. So curvature multiplied by dx, you get the d theta, okay? The change of theta from this point to this point, but as it is very small, okay? So you have tangent, one tangent is drawn from here to there. Another tangent is drawn from here to there, okay? This angle here is the equals to curvature multiplied by dx. Right? You want to get the d theta. D theta is the change of theta. So that is equals to curvature multiplied by dx. Curvature is the height and dx. Okay? And then you get the area, the change of theta. And then you get that change of theta, you multiply by this distance. So this distance measure from the centroid of this, okay, this rectangle to this point. So angle multiplied by the arm, okay, you will get this one. So what? Phi dx, and then you multiply by the distance. I call it di, okay, for this little element, okay, and then you do the same thing, same all. So this segment, this segment, this segment, this segment, this segment. So integrate everything. You integrate everything, then you will get the area multiplied by the distance from the centroid of this shape to the point B. That's how you come up with the idea from the moment area theorem to find out the deflection. Okay, that's not what we are going to focus so much, but it has a reason behind. It is not just purely mathematics, all right? It has a physical meaning, so I think you better get to understand something like this. So for this, if you want to find this point, which is referred to this tangent from the other point, okay? So you take this area, which is the PL square over 2EI multiplied by the distance to the centroid of this shape. Distance to the centroid is 2/3 of L, okay? You end up with PL cubed over 3EI going upward. So next we consider this system. The system that you have the moment M applied at the tip. Alright. So you apply moment at the tip, you produce this bending moment diagram. You have the M here, M there. You have no vertical force involved with this system. Okay, you don't apply any vertical force, then you have the zero vertical force. And then you end up with the M over EI diagram, looks like a rectangle shape. Okay. So theta M is equals to M L over EI. Okay. L over EI. And delta M is equal to ML over EI times distance from centroid L over 2 ML square over 2EI going downward. Now, in order to add these two systems, okay, first let me ask you what are the unknowns for now? we have the P